Welcome to Kanerika's podcast, The Digital Shift.
Thank you. It's great to be here to talk about this.
Yeah, I'm really excited for this one. So I want you to imagine writing a check for $10 million to build, a cutting-edge artificial intelligence system.
Right. A massive investment.
Exactly. And then you just watch it sit on a server, completely unusable by your team, and it's just quietly draining resources.
That's a nightmare scenario.
But that scenario is playing out right now in Fortune 500 companies across the globe. We are seeing this massive industry paradox where organizations are pouring, just tremendous budgets into AI initiatives, yet a staggering number of these projects just stall.
They absolutely do.
They turn into these permanent pilots that never see the light of production. So our mission today is to uncover exactly why this happens, and more importantly, how to successfully navigate the really complex landscape of building enterprise AI.
Because getting it right is crucial.
It really is. Whether you are an executive planning a corporate-wide rollout, or maybe a technical lead tasked with system integration, or just a professional looking to understand the future of digital workflows, getting this architecture and staffing right is the difference between a system that transforms your business and one that just becomes an expensive paperweight.
That paradox is a daily reality. And, it is costing enterprises a fortune right now.
Oh, I bet.
When you look closely at these stalled initiatives, the biggest source of wasted budget, it rarely stems from the technology itself.
Really?
Yeah. It almost always comes down to a fundamental misunderstanding of the specialized roles required to build modern AI solutions. Companies are effectively trying to hire for a position that they just haven't properly defined, which throws the entire project off balance from day one.
I see this constantly on job boards, actually. An organization will post a generic listing for an AI developer with this massive laundry list of requirements.
Yes, the everything to everyone job post.
Exactly.
Yeah.
But posting a generic title like that just attracts completely mismatched candidates, right? The resumes that land on the hiring manager's desk might as well be for entirely different professions.
They often are. We really have to draw a hard dividing line right away. On one side of the spectrum, you have your machine learning engineer.
Okay.
This is a highly quantitative professional. They are focused heavily on statistics, optimization theory, and training custom predictive models from scratch using raw data.
So they are the ones doing the heavy math.
Exactly. They live in frameworks like PyTorch or TensorFlow, building things like custom fraud detection algorithms or, proprietary recommendation engines. But on the other side, you have the generative AI developer.
Right.
This is an applied engineer.
Mm-hmm.
Their primary job is to call, orchestrate, and productionize pre-trained foundation models via APIs. They are not building the underlying cognitive engine.
Got it.
They are integrating that engine into functional software.
Okay, let's unpack this. Because I think I have a good way to picture this. Hiring a machine learning engineer when you actually need a generative AI developer is kind of like hiring a metallurgist to build a skyscraper.
Oh, that's a great comparison.
Right, because the metallurgist knows exactly how to forge the steel from raw iron at a chemical level, and that is incredibly valuable.
Absolutely.
But if your goal is to construct a functional building, you actually just needed a seasoned architect to assemble the prefabricated steel beams into a usable structure.
That is a very apt way to look at it.
Right.
And the real-world impact of confusing those two roles is severe.
How so?
Well, if a hiring manager screens a generative AI candidate with complex machine learning statistics questions, they are going to filter out the exact builders they need to actually ship a product feature quickly.
Because they're asking the wrong questions.
All right. And conversely, if you hire a brilliant machine learning engineer to build a conversational interface on top of an existing commercial model, they might completely lack the applied software orchestration skills needed to make that feature reliable for end users. You simply have to know what you're building before you know who you are hiring.
That makes total sense.
Yeah.
And that raises the obvious next question. If we need this architect of pre-trained models, what exactly are they constructing in the enterprise space? We hear so many buzzwords, but what do the actual deliverables look like?
When you cut through the noise, the deliverables tend to fall into a few recurring categories. The most urgent one for businesses right now is retrieval augmented generation.
Also known as a RAG, right?
Yes, RA. Instead of relying on the generic data a public model was trained on, which, as we know, often leads to hallucinations, A RAG system grounds the AI's answers entirely in your proprietary internal documents.
Which is critical because nobody wants an AI making up corporate policy on the fly.
Definitely not.
But beyond just answering questions, I see companies pushing hard for interactive tools.
Yes. The next major focus is embedded conversational interfaces, like copilots. But the true engineering challenge here is not just, putting a chat window on a website. No, the real challenge is context management. Keeping a model on track and logically consistent across a lengthy, complex conversation is remarkably difficult.
I can actually relate to that on a personal level. I tried to use a standard language model to help me outline a complex research project last month.
How did that go?
Well, for the first 10 minutes, it was brilliant. But by minute 20, it had completely forgotten the core constraints we agreed upon in minute 2.
Yeah, that's very common.
It was like talking to a very enthusiastic colleague with severe short-term memory loss.
That memory loss happens because models have strict token limits. They can only, quote-unquote, remember a certain amount of text at a time.
Ah, okay.
So a skilled developer has to build systems to compress, summarize, and inject relevant history back into the conversation seamlessly. And if we take that a step further, we move from chatbots to AI agents.
And agents are different because they actually do things, right?
Exactly. Agents do not just respond with text, they take action. They are systems designed to call external tools, write code, and plan multi-step tasks autonomously.
So an agent might receive a prompt, realize it needs to check a database, run a query, analyze the result, and then send an email based on its findings, all without human intervention.
Correct. It is a massive leap in complexity. Then you also have developers focusing on structured data generation.
What does that entail?
That means building pipelines that automatically extract specific liability clauses from thousands of legal contracts at scale, for example. And finally, you have fine-tuning.
Ah, fine-tuning. I always hear fine-tuning thrown around as the ultimate solution to everything.
It is often misunderstood. Fine-tuning involves selectively adapting the model's actual weights using methods like low-rank adaptation or to teach it highly specific domain vocabulary.
But it's not a silver bullet.
Not at all. A mature developer knows to reach for fine-tuning only when retrieval, that initial arity architecture we talked about, genuinely cannot solve the problem.
Yeah.
Fine-tuning teaches a model how to speak your language, but RAG gives it the actual facts to reference.
That's a great distinction.
Most enterprise teams initially need an application-focused generalist with incredibly strong RAG fundamentals, not necessarily someone who spends all their time tweaking model weights.
Right. Okay, so to build any of these applications, developers rely on a highly specific and rapidly evolving technology stack.
Yes, the stack is moving incredibly fast.
You have your LLM APIs from providers like OpenAI, Anthropic, or Gemini.
Yeah.
Then we hear constantly about orchestration frameworks, most notably LangChain and Llama Index.
Right.
But I want to challenge this for a second.
I'm for it.
Are orchestration frameworks like LangChain always strictly necessary? Or do they sometimes just add abstraction and overhead, overcomplicating something a good developer could just build with standard Python code?
That is a highly debated topic among software engineers right now, and honestly, it is the exact right question to ask.
Okay, glad I'm on the right track.
Frameworks like LangChain can absolutely add unnecessary overhead if you are just building a simple script. However, when we at Kanerika evaluate a system's architecture for an enterprise client, we often find that the difference between a fragile prototype and a robust, mature platform is LLMOps.
Large language model operations.
Exactly.
So what does that operational maturity actually look like in practice?
It is the progression from casually testing a prompt on a local laptop to running a hardened production system.
Okay.
It means automated evaluation. It means setting strict cost routing so an API doesn't just drain your budget overnight. And crucially, it involves tracing tools like Langsmith.
Why are tracing tools so important?
Because without tracing, if a prompt suddenly degrades in production, or if the model provider updates their foundation model and your outputs silently break, you have absolutely no way to catch the regression or trace it back to its root cause. The orchestration framework provides the plumbing to make that observability possible.
That makes a lot of sense. Let's talk about the other major piece of plumbing in that stack, vector databases. Tools like Pinecone, Qdrant, or pgvector.
Yes, vector databases are essential.
For anyone who isn't a database engineer, how does a vector database actually differ from a standard SQL database or a massive Excel spreadsheet?
I like to explain it this way. If a traditional SQL database is like a perfectly organized filing cabinet where you search for an exact match like, looking for the exact phrase Q3 revenue.
Mm.
A vector database is more like mapping the meaning of your data in three-dimensional space.
The meaning, not just the keywords.
Exactly. It converts text into mathematical coordinates. So if you search for financial performance in the fall, the vector database understands the conceptual proximity to Q3 revenue and retrieves it, even though the exact words do not match at all.
Wow. And that conceptual mapping is the absolute core of building a RAG system, right?
It is the absolute foundation.
Which brings us to a critical point. Because RAG is the most highly requested enterprise build, it essentially serves as the ultimate litmus test for a developer's genuine capability.
It absolutely does. If a developer claims they understand the LOM ups we just discussed, they should be able to execute RAG flawlessly. A production-ready RAG architecture has 5 distinct stages.
Okay, let's walk through those.
It begins with ingestion. That means cleaning and normalizing raw, messy enterprise data. Then comes chunking and embeddings.
Let's pause on chunking because I think a lot of people assume you just feed a whole document into the AI.
Oh, you cannot just feed a 500-page enterprise contract into a model. You have to break it down into retrievable units, or chunks. But if you just slice the document strictly by word count, you might cut a crucial liability clause perfectly in half.
Oh, I see.
The AI retrieves the first half of the sentence and has 0 context. A skilled developer writes logic to chunk documents semantically, by paragraph or by section header, so the meaning remains intact.
That is a subtle but massive difference.
It really is. After chunking, that data is stored in the vector database we just mentioned.
So we have ingested the data, chunked it intelligently, and stored it. Now a user asks a question. That brings us to retrieval and re-ranking. Wait, if I've already pulled the most conceptually similar documents from the database using that three-dimensional vector search, why do I need a whole separate step to re-rank them? Aren't they already the right documents?
You would think so, but the re-ranking trap is one of the most common pitfalls in AI development. Skipping the re-ranking step is often the primary reason AI answers feel close but wrong to the end user.
Interesting. Why is that?
Because vector search is based on mathematical similarity. But mathematical similarity does not always equal logical relevance.
Can you give an example of how that breaks down?
Sure. Imagine you have a database of company IT policies. A user asks, how do I connect my smartphone to the network? The vector search might pull up a highly mathematical match about the company cafeteria offering a new smart fruit initiative simply because the word mapping overlapped conceptually in a weird way.
Oh, wow. Smart fruit versus smartphone.
Exactly. A re-ranker applies a secondary, much more precise machine learning model to read those initial results and say, wait, the user is asking about IT infrastructure. This cafeteria document is mathematically similar but contextually useless. It reorders the chunks based on actual relevance before passing them to the generator.
That is fascinating.
If a candidate does not bring up re-ranking in an interview, they are likely building brittle, unreliable prototypes.
Which proves a major point for anyone trying to hire in this space. A resume or a portfolio link tells you almost nothing. I mean, anyone can follow a weekend tutorial, build a rudimentary chatbot, and list all these impressive tools on their profile.
Resumes are practically useless for assessing genuine capability here.
So how do you vet them?
The ultimate technical screen is a small, paid build. Give a candidate 20 pages of proprietary, messy internal documents and ask them to build a working Q&A system.
Put them to the test.
Yes. This single exercise forces them to make real decisions about chunking logic, embeddings, and retrieval strategy.
And to separate the real software engineers from the tutorial followers, you have to ask the killer questions during that vetting process.
You do.
The first is, how do you trace an accuracy failure back to its root cause?
Right, because if they cannot explain how to use tracing tools to dissect a failure, they have never managed a system in production.
Yeah. And the second critical question is, how do you stop an autonomous AI agent from looping indefinitely?
That one is huge. A strong answer requires a deep discussion about strict tool definitions, hard step limits, and programmatic guardrails. An agent without limits will continuously hallucinate intermediate steps, get confused, and frankly, consume massive amounts of API budget in a matter of minutes.
Yikes. So once you know how to properly vet the talent and ask those rigorous questions, the next hurdle is figuring out how to actually engage them without breaking the budget or slowing down your innovation roadmap. Because the talent pool for production-tested AI builders is incredibly thin right now.
It's incredibly scarce, which drives rates up. You generally have 4 engagement models to choose from.
Okay, what are they?
First, you have the full-time employee, which offers the highest knowledge retention but comes with a massive cost and a multi-month recruiting cycle. Second, you have the freelance model, which is fast, but the intellectual property and institutional knowledge literally walk out the door when the contract ends.
Right.
Third, you have staff augmentation, where you embed external talent directly into your team at a predictable rate. And finally, managed delivery, which is entirely outcome-based.
Okay, here's where it gets really interesting. When you bypass that multi-month recruiting cycle and deploy specialized talent through staff augmentation or managed delivery, the real-world implications are staggering.
They really are.
We are looking at metrics where leveraging a context-aware AI agent cut mismatched expert recommendations by 80% for a global network platform. Furthermore, utilizing LLM-powered agreement processing cut vendor selection time by 90%, all while reducing manual reporting effort by 55%. Those are transformative bottom-line numbers.
They are, but I have to add a caveat. Those numbers are only achievable if the system is built with strict compliance in mind from the very beginning.
Especially in regulated spaces.
Exactly. In regulated industries like finance, healthcare, and legal, raw coding capability is simply not enough. A developer must also deeply understand data residency laws. They need to implement immutable audit logging so you know exactly why an AI made a specific decision. And they must design human-in-the-loop workflows.
Right.
You cannot simply point an autonomous model at sensitive patient records or financial data without inviting severe legal repercussions.
Which brings us to the most frustrating part of this entire landscape. Let's say a company does everything right. We have the right roles defined, the right technology stack selected, and the optimal hiring model in place. So why do so many of these projects still hit a brick wall?
Because stalled projects rarely stem from a lack of coding ability. They fail due to systemic organizational blind spots.
Like what?
Well, they fail because of missing governance. Perhaps there is no defined data residency policy, so the security team just shuts the project down right before launch.
Oh, that happens all the time.
They fail because of a weak retrieval architecture, where the model hallucinates simply because it is being fed garbage context.
Garbage in, garbage out.
Exactly. They fail due to a lack of evaluation discipline. Teams ship a model without automated regression testing. And most critically, they fail due to zero executive ownership. Without a business leader accountable for the final outcome, the project just drifts endlessly.
So to avoid those failures, executives and technical leads need a clear red flags checklist.
Yes.
First, watch out for treating a prompt engineer as a full-stack developer. Writing a clever prompt is not software engineering.
Not at all.
Second, lacking vector database experience is an immediate disqualifier for enterprise builds. Third, choosing the underlying foundational model before defining the actual business problem is just a recipe for disaster.
Agreed.
And finally, ignoring security is an unacceptable risk.
Security is paramount. A classic example is failing to understand OSP guidance for prompt injection attacks.
What does that look like?
If a user can type a malicious prompt that tricks your AI agent into ignoring its instructions, and that agent have unauthorized read-write access to your database, your entire enterprise system is compromised. Security and governance must be architectural prerequisites, not just afterthoughts bolted on at the end.
As we at Kanerika have seen firsthand, successful AI isn't just about hiring someone who can type Python code fast. It is a holistic discipline.
It really is.
It is about assessing your data readiness long before you begin. It is about designing a comprehensive, heavily tested RU architecture before writing a single line of production code. And it is about handing over transparent governance documentation rather than delivering a mysterious black box to your stakeholders.
Yeah, that holistic approach is truly the only way to ensure the system survives contact with real users and delivers tangible ROI.
So what does this all mean? It means that to succeed in this landscape, you must focus relentlessly on the system as a whole. The underlying foundation model, whether it's from OpenAI, Google, or an open source provider, is merely the engine.
Right.
You have to build the transmission, the steering wheel, and the brakes. You have to build the rest of the car.
That is a crucial takeaway. And as we conclude, I want to leave you with a final forward-looking concept to deeply consider.
Okay, let's hear it.
We've talked extensively today about building AI agents that can plan and execute tasks for your own business. But in the very near future, your enterprise's AI agent will inevitably need to negotiate, schedule, or collaborate directly with a vendor's AI agent.
Wow, agent to agent.
Yes. When two autonomous systems are interacting, transacting, and compromising without human intervention, how do you design the guardrails to ensure your agent negotiates in your best interest? And when those two algorithms reach a binding agreement, who ultimately owns that outcome?
That is a profound question for the future of enterprise architecture, and definitely a scenario we are going to see play out very soon. Thank you for joining the Digital Shift. Keep exploring the digital frontier, and we will see you next time.